Lynn asked me to talk about telomeres. This is actually, does anyone know what this is? Picture of? It's a chromosome. It's an electron microscope of chromosome, and it shows those bright bits on the ends of the telomeres. So it's a bit like a shoelace, with at the end you've got the plastic bits that coat the shoelace. And as you get older, that plastic bit gets shorter and shorter. And once it gets to a certain 13 sequences, the shoelace itself starts to fray and your cells start to die. And that's what happens to our cells. That's what happens in aging. And this is, in a way, a nice biomarker of aging. And we've been using it because we're very interested in the tweet in studying the disease of aging and the aging process. And we found some remarkable things to do with this. So first of all, we found that, yes, levels of the telomere change with age. They go down, on average, quite a lot between the age of 20 and 70, 80. That men have shorter telomeres than women by an average of about 7 years, which would fit with their life expectancy. We're just not built to last. And also that we found that certain environments are important. So you can reduce your telomeres if you smoke, if you're fat, if you don't exercise, and strangely, if you marry the wrong husband. It can seriously shorten your life. So we had some really interesting studies of identical twins where one had married someone in a top social class, rich, successful, had a great lifestyle, and the other one had married someone lower down the scale, and we compared these pairs of otherwise identical people, looked at their telomeres, adjusted for everything, and we found about a 5-year difference in lifespan between them. So pick the right partner, girls, very important. We don't know whether that was the stress or actually the health, the lifestyle, because some of it is due to stress, and we've also shown that extreme stress can actually shorten your telomeres. So it's a lovely little marker of aging, and it allows us also to do genetic experiments and work out the genes for aging. So we've found about 3 major genes that control the telomeres, such that some people are naturally born with much higher, longer telomeres than others, and so some 70-year-olds have the telomeres of a 30-year-old, and vice versa. So within every population, there are all these extremes. Now, the only problem is, you might say it's great to have lots of telomeres, very good for aging, but not quite so good because it does increase your risk of cancer. Because in a way, the aging process is there to slightly, as a dampener on the cancer cells. Because what it means is your cells aren't dying as quickly, and therefore there isn't that mechanism that copes with when errors come and you get cancer. So like everything, there's no easy answer. And a good example of this is we found, working with a dermatologist, that the number of moles people have, so not talking about freckles, but the larger brown flat moles that people have, which you start when you're about 4 or 5 years old, you slowly build them up until your maximum between about 30 and 40. You'd be really moly, and then they start to get less again. That was a marker of aging. So the number of moles is actually related to your telomeres. And observations have shown us, and from dermatologists, that actually people with lots of moles look much younger. They're baby faces. And the telomeres also confirm that. So people with lots of moles have longer telomeres. But people with lots of moles do get rare skin cancers more often. So there's always a trade-off. There's no easy ticket. But some of these things, only came out from studying lots of weird things that we didn't think are related in twins.